you ready to master the waves of medical device product development? Well, wax up your surfboard because you are listening to Inspired by Imua. And here is your medical device product development expert, that Hawaiian-hearted hostess who will help you hang 10, Meghan Alonso.
E como mai and aloha. You're listening to Inspired by Imua, where we help you master the waves of medical product development. Each week, we interview guests that educate, guide, and inspire to give you and your product the skills you need to hang 10. If this is your first time listening, Imua is spelled I-M-U-A, and it's a Hawaiian word. It means to advance forward with passion despite rough waves. There are plenty of those in medical device development, but keep listening because we've got you covered. So as I'm recording this episode, Lab on a Chip World Congress in San Diego has just wrapped up. So it's a multi-track conference going on, and it specializes in quite a few things actually. So Lab on a Chip is what it's called, but there's point of care technologies, there's next generation sequencing technologies. All of this is related to the diagnostics world, and some pretty cool things are happening in that. Lab on a Chip traditionally was used for diagnosis, so utilizing small channels instead of a more traditional lateral flow test, like a pregnancy test. So this is taking a small sample of whether it's blood or urine or saliva and running it through some serpentine channels with some reagents, and you get your answer, positive, negative, a quantitative result with how much of a particular pathogen is there. But it's also kind of reignited the CD industry. So there's a lot of lab on a chip technology utilizing old CDs. Like you look at a CD player, and they've taken that technology and used it like a centrifuge. So you have your sample in the middle, and the sample is spun out as it's being rotated. So literally looks like a CD, which is pretty cool. One of the keynotes was Dr. Robert Schuler, who's working on, so after lab on a chip, we've had organ on a chip, we've had body on a chip, and that's what he has really spearheaded. And the cool thing about that is he just won an award last year. Let's see, which award was it? 2015 Lush Prize for Science, and this was based on, we're getting away from using animals for models in testing new drugs. So what you can do with these organs on a chip, and in particular the bodies on a chip, is all of the tissue that these systems are built with, they take on human properties because they're made of human cells. They can stimulate the human metabolism, the human functions, and even the toxic side effects, as well as testing how efficacious are these drugs, and are they going to work? And all this is done without using animals at all, which is pretty cool. So one fact that I thought was pretty shocking, for every 50 drugs that are deemed safe for animals, only one of those is proven safe for humans. So this is a way that we can really just jump that whole process of working with animals and just go straight to humans anyway, which is a lot more applicable. So I've captured some audio from this show, so I'm going to just play those audio clips so you can have a peek into that particular conference and what's happening in the Lab on a Chip world.
Hi, my name is Mike Gavin. I'm here with Porta Science, working with IW Tremont. We're exhibiting here at the Microfluidics Conference. IW Tremont produces lots of different materials used in microfluidics and lateral flow type assays. For me tonight, Bernard Weigel, his discussion about lateral flow devices in particular was really quite interesting, because nobody's really tried to work that hard to understand really the fundamentals of the limitations of lateral flow devices. And many of the things he talked about tonight would lead you to think that we could see tenfold or 100-fold improvements in sensitivity and still retain that great simplicity and low-cost structure of lateral flow devices. So it's early in the conference, but for me, tonight, that was one of the better talks that I saw. A lot of the other stuff went right over my head, but that I kind of understood.
Hello, my name is Kamlesh Patel. I'm from Sandia National Laboratories in Livermore, California. I'll be speaking tomorrow on the topic of nanopore sequencing and sample prep technology that you can couple with sample prep for nanopore sequencing for fieldable sequencing technology. So one of the main points I think I'd like to have folks take away from this talk is the fact that nanopore sequencing is real. And it's actually beyond just a play toy, and it actually is right at the cusp of being a pretty real sequencing technology for the field. And it's going to be pretty much a groundbreaking approach on how people are going to use this technology for diagnostics and how it's going to change the way we look at information and how we collect information for sequencing, now that we can get that fundamental level of what's wrong with you, what's going on from a public health perspective, or even diagnostics of trying to get the answer quicker than you could with a conventional approaches.
So for those that aren't as familiar with diagnostic, maybe there's people listening that have a background in orthopedics, explain what that is a little bit more and why it's so groundbreaking, why it's better than the more traditional lateral flow style pregnancy test or maybe even the lab on a chip test.
Sure. So from my perspective, I work at a government lab, and so the scenario that's best to explain this is kind of the public health. So you think about, let's say, Zika. You have Zika in a certain area, and everybody's worried, well, do I have it or do I not? And so you have folks that are worried, and we call them the worried well. They're not infected, but they think that they're sick, and they're going to go to the hospitals nonetheless and ask, hey, I think I'm sick. And then you have people who are really sick. And so, unfortunately, it puts a real strain on the public health system when you have people who are worried well and the folks who are actually perhaps sick. And so if you can quickly screen out the ones that are sick versus not sick, that really allows you to save your intensive resources for the folks that are sick. And you can screen out the ones that aren't and say, no, you're not sick with Zika. You may have the flu or some other ailment that are causing the symptomatic response. So that's one scenario that diagnostics in the field or point of care or point of need really helps screen a lot of these kind of cases and scenarios.
We all break out knives.
So you are with Sandia National Lab, so I imagine you have some government funding that you're working with. What are, along that same vein, what are some other initiatives, public health initiatives that you guys are working on?
Sure. So public health is a pretty broad spectrum. Within that, you think about, you can think of it from an international perspective and also a homeland perspective. And so we have programs that are working with areas like West Africa and South America, where it's one thing to have detection and disease diagnostics in the United States, but really in this concept of one health, one global health, you really got to go to the source where a lot of these diseases are emanating. So empowering countries in West Africa and South America with technology really makes the big difference, and it prevents it even coming to this country. So you do protection in the United States, but also globally, and it makes a big difference. So.
Protecting the herd.
Yeah.
Well, thank you very much.
Hi, I'm Steve Malish, Chief Commercial Officer of Fusion Biotech.
And Bruce Sargent, CTO. No, wait a minute. Come on.
CEO.
And CEO of Fusion Biotech. And we're here today to walk the show.
So tell me a little bit about why you came to this show and what you think about it.
Yeah, so the reason we came to the show is because Fusion Biotech does instrumentation and our core competency is diagnostics. So we tend to work with the groups that do lab on a chip and microfluidics, and we provide the instrument that goes around it. So part of the reason is to come down and see the show. This is our first time here, And the other part of the reason is to see who the players are and what they offer.
So what do you think is beneficial for the first-time entrepreneur that's looking to get into microfluidics?
This is a great show to get exposure to all the different technologies that are used to do these chips and how they work and who makes them and how they're made.
And we know a number of the speakers and have worked with a number of the groups here for a long time. So if someone comes to the show, sits in on some of the presentations, they're listening to folks that have been in the industry for 10, 20, 25 years or so.
That's good. And have you seen any breakthrough? Okay, no, we haven't.
No, I mean, this is...
I can talk about them.
I think my
what are
thing here is that you keep seeing every year, although I haven't been to the show, more and more people are getting into the space.
Okay, so talk...
Stratec is now in the space, so you start seeing more people.
Okay,
so it's a growing industry.
So we'll start over and talk about that then. So what are some of the trends that you've seen in lab on a chip and microfluidics, or is it a growing industry?
That's interesting that you mentioned that, Megan. One of the things that I've noticed even at AACC is that you start seeing more folks that are in the microfluidics industry and the disposable cartridges. So, and you're seeing that here at Lab on a Chip too, that some of the groups that recently got into doing disposable cartridges are exhibiting here as well as some of the other shows. So it is a growing industry because this is just a growing area. Point of care has been growing for the last, it's been 15, 20 years now, and will probably continue to grow. And I think the last article I read, it should be growing at about 10% a year. So it's a good growth area.
Yeah, a few years ago, it was all about lab on a chip, and it's still about lab on a chip, but then you started to see organ on a chip, and then now there's body on a chip, and it's definitely progressing.
Yeah, and there's the implantable chips now for artificial retinas, and they're coming up with small implantables to go around nerves for nerve stimulation, and so whether it's microfluidics, whether it's lab on a chip or other implantable chips, I think there's a lot of growth in this space.
Hi, this is Tom Dahl from LASIX Micromet Solutions Group. It was a great year this year at the Lab on a Chip assembly show out here in conference, but met a lot of neat people, a lot of good talks going on, and so very enjoyable show.
So what is the most intriguing thing that you saw this year?
Really the key thing here is all the different technologies that are going on and how they interrelate with the things that these people are trying to develop and design. So it's kind of fun being involved with a team of networking people that can do those types of things.
Good. Well, thank you.
You're very welcome.
So my next guest that you'll hear, Ned from Plasmara, brings up a lot of points I know that sometimes you guys are struggling with because I've heard it before. So I want you to listen carefully to what he has. He didn't come from the science industry. He started in the semiconductor industry and saw some opportunities going on over there that really could be applicable to science. But he's had somewhat of a hard time getting there and getting connected to the right people, learning the language in his particular niche that he really needs to advance his product forward. And I'm working on that. I really want to help people with that. If you have any other feedback, in addition to what he's saying, I'd love to hear it. You can tweet me. It's at Meghan M. Alonso. That's Meghan M. Alonso is Alonso. Or you can email me. It's malonso@imua-services.com. I'd love to hear. And I'm launching a beta program this fall that addresses a lot of these issues. So if you're interested in that, I'm offering 10 spots at no charge in exchange for feedback. And then when the program launches for real, you get to take that version for free also. So to learn more about that, you can text the word invention to 44222. That's all one word, invention, to the number 44222, or you can check it out on the website. Just go to imua-services.com/IIPP. That's IIPP for invention idea to profitable product. So without further ado, here's Ned. I have Ned Soleil with me with Plasmara. And Ned, tell us a little bit about what you're working on.
Hi, Megan. Good to see you again. Thanks for this opportunity. So Plasmara is a new startup. We are at seed funding, and we are located in the Silicon Valley between San Jose and Berkeley. We basically invented new technology for surface treatment using proprietary microplasma probes. Our niche really is selective, high-resolution treatment of surfaces, columns, pillars, channels, and even blank substrates. We focus on dimensions below 200 microns where conventional plasma treatment is not possible or it's too destructive for substrates. We know this is an emerging need in the market as applications are trending towards smaller dimensions in various bio applications. Mm-hmm. So we are out talking about our technology, learning about opportunities that we can synergize with. And we come from mostly semiconductor fabrication background. So we bring a lot of techniques of processing, inspections, yield improvement from the semiconductor industry where dimensions really make a lot of difference into microfluidics and various bioengineering applications where smaller dimensions, functionalization of these dimensions enables a lot of applications that were thought inaccessible before because of the lack of both the fabrication and functionalization technology.
Yeah, that's really great. I'm always a big advocate of looking what other industries are doing and how we can steal or how we can look at what someone's doing and bring it over for biotech and medical diagnostics. So what's one of the biggest struggles you've had as a startup unfamiliar with the biotech and microfluidic space that you can share with our listeners and maybe give them some tips about?
Yeah. Actually, we had challenges across the board. As I mentioned, the know-how of microfabrication at the few micron level, maybe 10 micron and going down to submicron, as you might imagine the sequencing application would require. A lot of these techniques come from conventional semiconductor fabrication, where technicians and engineers and scientists came from engineering background with very little knowledge in biology or medical application. So one of the main challenges we had is we knew our technology will be very enabling in the microfluidics and bioengineering applications, but we were not able to access these applications and markets. The specific opportunities and building a business model and investor pitch were not very clear to us. So we had to outreach, learn by mistake. The conventional thinking from the semiconductor industry doesn't really work most of the time. For example, thinking along increasing value of your sample along the lines of Moore's law, where densification reduces value per item or unit, and that with the economics of volume would basically expand the proliferation opportunities. It doesn't quite work that well. There are certain limitations in the bioengineering and specifically microfluidics world where the Moore's law thinking has to be sometimes significantly modified, but still it works. If you can invent technology that enables fabrication, inspection, functionalization, and yield improvement, it would still be very useful. Mm-hmm. So reaching out to the unmet needs in the microfluidics, various bioengineering applications was not easy. It's a sector of practitioners which we usually don't know. We have not been with them in grad school. We haven't worked with these companies. We don't go to their conferences. So it was a barrier that we had to penetrate to understand their needs, where value propositions have to be made. Reaching out to investors in that sector also was not obvious to us. We were asking the wrong set of investors from other fields, from software and semiconductor industry, who did not appreciate the value of our startup. So reaching out to investors, putting together an effective business plan and investment pitch was one of the challenges. And once we have learned about that the hard way, several years of pitching till we actually were successful in raising seed funds that would help us work full-time for our startup. The next challenge was to find the right set of vendors and fast prototyping companies to work with. And again, we had to make a number of mistakes to find the right one for us. So I think this journey, which doesn't stop there, we still have challenges in market penetration. This journey can be shortened. There's a gap to bring entrepreneurs from the semiconductor industry into bioengineering across the board, really. So it's everything. It's putting together a pitch, identifying market opportunities, the technologies that can be transferred from the semiconductor industry into microfluidics and bioengineering need to be better identified. Putting together startups with appropriate boards also is another field that we are struggling with. So I think there is a gap that will widen with time as the need for more nanotechnology, sensors, and microfluidics applications is increasing. This gap in bringing in entrepreneurs will continue to increase. So this is an opportunity for maybe a company like Toolbox to provide help for entrepreneurs.
Yeah, well, thank you for all that feedback, and I'm planning on putting some resources on the website. So if you check out imua-services.com, there'll be some resources exactly for that. And thank you so much. It was awesome to speak with you today.
Yeah, thank you for having me.
Okay. Well, that wraps it up for the audio from Lab on a Chip Conference of 2016. If you found this pretty interesting and want me to cover other conferences, any in particular that are coming up, just let me know. I'll be more than happy to reach out to the conference organizers and see if I have permission to do that and let you guys know about it and give you the full report even more in depth than this as I'm growing this part of my business. So happy to have you with me today. Have a great rest of the week. And until the next episode, Imua.
Mahalo for joining us. If you're new to riding the waves of medical device product development, or if you've been in development for a while already, Inspired by Imua is here to surf with you. Want to be a master of the waves? Text HANG10, that's all one word, HANGTEN, to 44222. We'll send you the most common wipeouts companies make in product development so you can avoid them and reach master wave status. Again, that's HANG10 to 44222. We publish a new episode every Tuesday, so catch us at inspiredbyimua.com. Imua.